What's going on there, geometry peeps? Now, today we're talking about flow proofs. Flow proofs are exactly like two-column proofs. It's just another method of communication, another way to show your work, another way to communicate these geometric topics in a new format. So be able to represent it in multiple ways and do it like this as well. So let's label our diagram here, RACE, the race is on. Okay, so it's exactly like a two-column proof. So if you really understand a two-column proof, this isn't going to be much difficult. So we always start with our givens. The only thing is the information from our givens go in the box. So AR is congruent to ER as my first given, and the reason goes under the box, which in this case would be given. We've proved something congruent, mark it up, check it off. No different than what we've done in the past. Now, this information is going to another piece of information. So I'm going to draw an arrow there, but I'm going to explain what that means in a little bit. So then we move on to our second given. AC is congruent to EC. That's given to us. We've proved something congruent. We check up our diagram and mark it off. Now we have to go in search of the third piece because we're out of givens. So we see that RC is congruent to itself. So I'm going to say RC is congruent to RC because of the reflexive property. So the same as a two-column. We mark it up. Okay, and again, this information's going to there. This information's going to there. And we now have 3 tick marks. So I can conclude that triangle RAC is congruent to triangle REC. And my reason is side, side, side. Alright, so sometimes it's easier to track our information that after you complete this, if you know you proved a side, you could write side. Here we proved another side. Here we proved another side. So at least you know what 3 pieces you're looking for. It's not mandatory, but another way to help organize our information. So really the main purpose here is to kind of create a flow chart, alright, of all the information heading to the same spot where we can draw our conclusion once all that information is given. Alright, so that's all a flow proof is, another way to organize our ideas and represent it differently. Okay, so here's another one. And again, eventually we're going to take the squares away and we're going to have to do it on our own. So the squares here now are just kind of to help guide us through the proof. Okay, so we're going to start with our first given again. In this case, C is a midpoint of AE. So C is, let me move that up a little. C is the midpoint of AE, and that information was given to us. Now we haven't proved anything congruent yet, but we know a midpoint cuts it in half, so it's the midpoint of AE. So C we know cuts this piece in half, so let's communicate that. So we have AC is congruent to CE because if it's a midpoint, then it cuts a segment into 2 congruent segments. Midpoint cuts a segment in half, or into 2 congruent segments, however you want to communicate that. Okay, so that's our first piece. So this information came from here to here, and eventually we want to go here, and we've communicated that we proved a side congruent, if that helps you. Alright, so we use that given we proved something congruent. Let's go on to my next one, which is BC is congruent to CD. We've proved something congruent. Mark it up, check it off. And here we've proved another side congruent. Alright, we're all heading to that conclusion. We're out of given, so let's look at our diagram and see what we got here. Alright, so now we're looking at this, and I see I have vertical angles. So I'm going to say angle ACB is congruent to angle DCE. My reason being vertical angles are congruent. If vertical angles exist, then we have congruent angles. Oops, over here I forgot to label my given. So I'm going to make sure that reason's in there. Then here we have congruent angles. Now, you have to be careful because we don't necessarily name our method by what we proved. We've just proved 3 pieces. We always have to go back to the diagram to make that decision. So it's side, angle, side. And here is our proof statement. Triangle ABC is congruent to triangle ECD. So we've justified those 2 triangles are congruent. We know side, angle, side holds true all the time. And that's kind of how our flow proof goes. Now here, notice we had 2 steps flowing into 1, and these were just 1 steps. So it's aligned a little differently. Not a big deal though. It's flow. This idea comes from here, feeds in. This idea. Just another way to represent and another way to model. Alright, one last one. Now this one, we get no guidance. Now, this one, I'm actually going to do a flow chart up and down. Alright, I'm not going to do it left to right. Left to right is how you'll see most of the formats in your worksheets and stuff, but I just want to show you that there are other ways out there. So let's start with our first given. We have DC is perpendicular to UK. Now, we know that these givens, okay, with a perpendicular given, it typically takes 3 steps to prove something congruent. Alright, so I'm going to zoom out here so we have a little more room. And so what this proves to me is that we have right angles. So we know DCU and DCK are right angles. So angle DCU and angle DCK are right angles. And I'm going to put this one in a box. Ooh. Alright, now we know that. We know this because perpendicular lines create right angles. Alright, so that's my reason. We had lines up there, so you can put lines there if you want. And now this heads to what we're going to say is congruent. So we have angle DCU is congruent to angle DCK because all right angles are congruent. Alright, so there's my statements with my reasons underneath. Alright, and we got to see how this all flows together. Okay, now, so we've taken care of that, and ultimately what's happening is we're going to this main idea. Alright, so we proved something congruent. We can check it off and move on to my next one, which is DU is congruent to DK, and that's given. Alright, and we know that, so that's going to feed into something. Now, I've proved something congruent there. Okay, oh, wrong ones, my mistake. So DU is congruent to DK, and then we have our third piece, which is DC is congruent to DC by reflexive. Alright, so here we have that. And we're all going to the main idea, which is to prove the triangle's congruent. So we can see our statement there. So let's make that a box. And we have triangle DUC is congruent to triangle DKC. And now let's go look at what our method is. So here we have an angle side-side relationship, but we know that's not allowed unless we have a right angle, which we do. So we have our hypotenuse and our leg. So here was my right angle, here was my hypotenuse, and here was my leg. So we can say they're congruent by HL. Alright, so just another way to represent it, going up and down, or however you want to visualize it. Notice the idea from the blue came in here, the idea from the black ink came in there, the idea from the red ink came in there, and we all lead to one central idea. Alright, so that's the whole idea and the premise behind a flow proof, and another way to represent it. That's all I got.